Hello and welcome back. Now in this tutorial, I'm going to build a stack using linked list. We have learned about stack earlier and we have also developed various operations on linked list. We are not going to do anything new in this tutorial. Rather, we'll be using the operations that we have already built for linked list for developing a stack using linked list. So we can just use the insert at head operation as push operation for a stack and then delete first, that is deleting the first node of the linked list as the pop operation to build a stack or to simulate a stack using linked list. So let me just elaborate this. Say we have an empty linked list right now, so the head will be null and tail will be null. Now if we call the insert at head operation, that's going to add the new node as the first node, and that's the only node, so the head and tail both are going to point this. So we have 10 as the node data. Now if you call this insert at head operation once more, then obviously it's going to add the new node as the first node. So the node that contains 10 right now will be moved to the second position. So we'll have this situation right now. 20 has been inserted as the new node and 10 is moved to the second position, and here we have null. So the tail is pointing to this second node right now because we have only two nodes there. Now if we call once more, then the situation is going to be something like this. So we called that insert at head once more with data 30. So that's going to be the first node. Now the 20 will be moved to the second position and the node that contains 10 will be moved to the third position. So the tail is going to point to this one, the last one. Now we see that the last inserted node is this one, the node that contains 30. So if we call the delete first operation right now, and we know that that deletes the first node, right? This one, that's going to delete this one. So if this is deleted and we get the 30 back, so it's actually performing the last in first out operations. The head will be moved to the second node right now. And now if you call the delete first operation once more, you are going to delete, that's going to delete this node and you are going to get 20. And finally, if you call that once more, then that's going to delete this one, and obviously we are going to get 10 and the linked list will become empty. That's the underflow state for the stack. So we can see that if we use the insert at head operation as our push operation and delete first as our pop operation, then obviously we are going to get the last in first out order for the data elements. So head is going to act as the top of the stack in this implementation, right? While we implemented a stack using array, we saw that the top was increased by 1 when we supposed to push, and when we popped out, then what we did, we actually decremented the top by 1 after getting the value from the top. So always we inserted at top and always we deleted from the top. So here we are inserting at head always and we are deleting from the head. That means the node that is pointed by head. So head is practically going to act as the top of the stack if we build the stack using linked list. So let's move ahead and see the code, how that code can be implemented. I've already written that. You can see that I've just copied those code insert at head and the delete first operation from the previous program. So here we have the same structures. We have this structure node and the structure linked list. Nothing has changed there, only we have copied these operations: init list, insert at head, and delete first and print last. Print last is just to print the total of the linked list so that we can display what are the content of the stack. So instead of naming this insert at head, I'd like to name that as push operation, because practically we are implementing a stack and push and pop will be more appropriate as the function name. So the init list remains same, it doesn't have anything new there, and insert at head, that has to be changed to push. So I'm changing that name to push. The operations are just same. The code inside push, if you notice, it's just same. I've just copied them from the previous program. So we are creating a node dynamically, and if the new node pointer is null, we are just printing the message there, unable to allocate new node. Otherwise we are just putting the data and the null to the next field, and then we are just checking whether it is the first node. If that is the first node, we are adding this node, address of this node to the head and tail pointer. Otherwise, we are actually adding that to the head and moving the current first node to the second place. And we are incrementing the node count. Print list is just same, and we have the delete first operation that's going to delete the first node of the linked list always if the linked list is not empty. So this is pop, and if the linked list is empty, we are returning just -9999 to indicate that the linked list is empty to the caller. Okay, and the code is just same. It's not something new there. And we are having a menu there, and I have just copied the stack operations. It's push, pop, and display. So if you call the push operation, it's going to push a new node into the linked list, and if you're calling the pop operation, it's going to delete the first node from the linked list. So here is the menu, and there are the callings. We have that while not quit loop. It's going to iterate as long as the user wish to continue with the linked list operations. And for case 1, it's the push. We are actually getting the data from the console, and we are calling the insert at head operation. It should be insert at head. So I'm just changing it to push because we have changed the name from insert at head to push. And this is going to be the pop operation, right? I've changed the name there. So we are all done. Now we can just go ahead and check how this works. Okay, I'll just open the console and compile this, and I'll run this. Okay, here we go. I'm just compiling that link stack.c. So it has been compiled, running that program. So we have this menu. Now if I call pop operation by choosing menu option 2, it will just say underflow. Here it is, because the linked list is empty right now. Now let me just push something there, 100. So that is pushed into the stack. Again, I'm pushing 200. Again, I'm pushing 300. Now if I call the operation pop, it's going to get me 300. Yes, that it is. So it is working fine. So it's a stack underflow. You can use the display operation to get the details of the linked list there. It's as usual. So that's how we can build the stack using linked list. In the next tutorial, I'll show you how we can build the queue using linked list. Thank you very much for watching.